हेलो एवरीवन। तो जैसे कि आपने थंबनेल देख के पता लगा ही लिया होगा कि आज की वीडियो किस चीज़ के ऊपर होने वाली है। तो एक्चुअली मैंने कृष्ण नाइक सर के साथ कोलैब करके एक एमएलओप्स का एंड टू एंड कोर्स पब्लिश किया यूडेमी पे, ठीक है? सो आपने एमएलओप्स का कोर्स मेरे चैनल पे ऑलरेडी देखा हुआ है, एक प्रोजेक्ट मैंने डाला हुआ है। अगर मैं उसका लेवल कंपेयर करूँ और इसमें मैंने जो 10 प्रोजेक्ट्स डाले हैं, सो वो कहीं पे भी नहीं आता उनके पास, ठीक है? तो इसमें बहुत ही एडवांस टूल्स का यूज़ किया है, लेटेस्ट टूल्स का यूज़ किया है और इन डेप्थ एक्सप्लेनेशन है हर प्रोजेक्ट के अंदर, ठीक है? और ऐसा नहीं है कि प्रोजेक्ट कुछ भी है, प्रोजेक्ट में यूज़ केसेस हैं, राइट? और एडवांस प्रोजेक्ट है, टेक्नोलॉजीज़ भी एडवांस है, प्रोजेक्ट भी एडवांस है, ठीक है? और प्री-रिक्विज़ाइट बोले तो एक होगा आपको पाइथन आनी चाहिए, नमपाई, पांडास आपको आनी चाहिए, मैटप्लॉटलिब, सीबॉर्न वगैरह। आपको मशीन लर्निंग आनी चाहिए, जो कि हम अपने चैनल पे ऑलरेडी कवर कर चुके हैं। तो अगर आपने वो सब पढ़ा हुआ है, तो आप बेझिझक इस कोर्स को ले सकते हैं। और अगर आपको डिस्काउंट अवेल करना है, तो मैंने जो डिस्क्रिप्शन में लिंक दिया, आप वहाँ से कोर्स लीजिए और मैं कूपन कोड भी दे दूँगा, जिससे आपको ऑलमोस्ट नेग्लिजिबल बैलेंस में आपको कोर्स मिल जाएगा, ठीक है? सो और ये मत सोचना कि मैंने अगर यूडेमी चालू कर दिया, तो अब मैं कंटेंट नहीं डालूँगा। यूट्यूब मेरा स्टिल एक्टिव रहेगा, वहाँ पे फ्री कंटेंट आता रहेगा आपको, तो आपको उसकी चिंता करने की ज़रूरत नहीं है, ठीक है? थैंक यू एंड हैप्पी लर्निंग। अब मैं यहाँ से एक वीडियो अटैच कर रहा हूँ, इंट्रोडक्शन वीडियो अपने कोर्स की, तो आप उसे देख सकते हैं और हाँ, पूरा कोर्स इंग्लिश में होने वाला है, ठीक है? सो हैप्पी लर्निंग। So before jumping into the tools and technologies that you will be using throughout your course, let's talk about the prerequisites that you need so that you can move ahead on your course journey. First of all, you should know basic Python. Okay. Then you should know about the four libraries. That is your NumPy, Pandas, Matplotlib, Seaborn. Okay. Then you should know also about machine learning concepts like your machine learning algorithms, how to implement them, all that. Okay. Because 80% of the projects that we have in our course are on machine learning. So if you know about machine learning thoroughly, okay, it will be a easy go. Now, that's all the prerequisite for our course. Let's talk about the tools and technologies that you will be learning throughout the course. So let me open the new slide. Okay, so these are the tools that you will be using in the project. First of all, we will be using GCP as our cloud platform. Okay, so you will be deploying your all the applications on GCP. Why GCP? Because when you make an account on GCP, it offers you a 90 days free trial with a $300 credit. And $300 credit is more than sufficient for testing purposes. Okay, so that's why we are going with our GCP. Okay, so we will be using various services of GCP like Google Artifact Registry, Google Container Registry. Okay, then your uh, Kubernetes engine, Google Kubernetes engine, and your Google VM instances, Google Cloud Run, like that. Okay, now next tools and technologies are first of all GitLab. Okay, now what GitLab do? GitLab is basically a CI/CD deployment tool, but it is also SCM tool also. SCM means your source code management. You know about GitHub, right? If you know about GitHub, GitLab can also do the same thing. It can store your code and all. Okay, but it also provides a inbuilt CI/CD pipeline tool. Okay, so you can deploy your any MLOps project using GitLab also. Next, we have Sipa CI. Sipa CI is also a CI/CD deployment tool. It is a cloud-based CI/CD deployment tool to be specific. So you can also using Circle CI deploy your MLOps projects. Okay, and we will be deploying into our Google Cloud platform. Remember, okay. And this is a very famous tool, GitHub Actions. You all know about that, okay? I think you all know about it, right? So it is very famous also in YouTube. Many videos are there on YouTube, but we will be using this for one of our project for deployment purpose. That is your GitHub Actions. So it is in your GitHub only. Then this is the most famous CI/CD deployment tool in the whole industry, Jenkins. More than 3000 plus companies uses Jenkins for their CI/CD purposes. Okay. So and most of the project that I have made in the whole course are using Jenkins only. So this is the most important. Okay. Out of all the CI/CD deployment tools, your GitLab, Circle CI, GitHub Actions, Jenkins. Jenkins is the most important. Okay, and Jenkins is open source also, unlike others. Okay, so this was it. And we have used in one of the project GitLab, in one of the project Circle CI, in one of the project GitHub Action, and in one of the project we have combined all the three: GitLab, Circle CI, GitHub Actions. Okay, and in I think 3 to 4 projects we have used Jenkins. Okay, now then you have GitOps. You will be learning GitOps technology also. What is GitOps basically? If I tell in summary, when your GitHub acts as a truth source. Now, what is this truth source and all? You will generally understand when you do the project. Okay, but for GitOps, you basically need one tool, that is your Argo CD. Okay, now what is the difference between Argo CD and other CI/CD deployment tools? Like, let's take the example for GitHub Actions. Okay, GitHub Actions can do both CI, that is a continuous integration, and CD part also, continuous deployment. But Argo CD has the name itself CD. Okay, so it can only do your continuous deployment part. Okay, but it is very useful. You can see in the next pic here also that there is a developer, then there is Git. Git is connected to your Argo CD, and Argo CD is connected to your Kubernetes. Okay, Argo CD is generally used when you are deploying your app to a Kubernetes server. Okay, then only Argo CD is used. Okay, and we have made one very important project. I will say that is the most uh, toughest project also. Okay, that is our GitOps project. Okay, so you will learn very new things from that project. Okay, now moving on, these are your experiment tracking tools. First one is your ML flow. I think everyone knows it. Okay, ML flow is generally used for your local experiment tracking tool. It is a local experiment tracking tool. It generally runs on your PC. Okay, local server. Then you have your Comet ML. So it is also experimentation tracking tool. But what is meant by experimentation tracking? Suppose you are doing your model training. Okay, you want to track the model. You want to track its metrics. So that is known as experimentation tracking. Okay, and these are your all tools. So you can use Comet ML. Unlike ML Flow, Comet ML is a online experimentation tool. Okay, so whatever you will run inside your PC will get stored on the online server, so you can see it from anywhere, any device. Okay, you can see all your experimentation in real time from anywhere. Okay, then we have TensorBoard. Okay, so you all will also be learning TensorBoard also. TensorBoard is a, we can say, a quick experimentation tracking tool. Okay, it doesn't have features like ML Flow, but it is quick to set up and all. Okay, so we have used this also in one of our project. Okay, but suppose if someone wants to use ML Flow in a online mode. Okay, you want to use a online experimentation tracking tool, but not Comet ML. You want to use ML Flow only. Okay, so what you can do, you can combine your ML Flow with your DAG sub. This you can see dog icon. Dog icon is your DAG sub. Okay, this is your DAX hub. Okay, so you can combine your DAG sub and ML Flow, and now ML Flow will become an online experiment tracking tool, like that. Okay, so we have discussed this also in one of our project, right? Now, for deployment purpose, I already told you we will be using Google Kubernetes. Okay, I told you we will be using Google Cloud, right? In Google Cloud, there is one of the service, that is your Google Kubernetes Engine, generally called as GKE. Okay, in short. So we will be deploying many of our apps on this only. Okay, GKE. But the problem with GKE is that basically in GKE, there are some limitations. Okay, you can't have a proper control on your Kubernetes servers. Okay, so what you can do, you can rent out a VM instance, install your own Kubernetes engine. Okay, and you can name it your with your own name. Suppose your name is Rahul, so you can name it Rahul Kubernetes engine. Okay, so for that purpose, what you can do, you can install a Minikube on your VM instance. So we have done that in one of our project. Okay, so Minikube can help you transform your PC into a Kubernetes server. Okay, so it can create a Kubernetes cluster on your local machine. Okay, so we have used Minikube in two projects. One project when we have done it locally, one project when we have done it uh, in a VM instance. Okay, Google Cloud VM instance. Okay, next we have our Kubeflow. Now, what is this Kubeflow used for? Basically, it is used for making ML flow orchestration pipelines. Okay, basically your ML flow training ML flow not machine learning training pipelines. Okay, suppose you want to make your training pipelines. Okay, and you want to deploy that project to a Kubeflow, a Kubernetes cluster. So you can make that training pipeline in Kubeflow also. Okay, so we have done that in one of our project where we have first set up a Minikube cluster on our local PC, then build a training pipeline using Kubeflow. Okay, so this is also an interesting project. Okay, Kubeflow. Now comes the in one of our project we have used data engineering concepts also. For data engineering concepts, basically we have made ETL pipelines. Data engineering ETL pipelines. ETL means extract, transform, load. For that, we have used Astro Airflow. Okay, so this is your icon for Astro Airflow. Okay, so what is Astro Airflow? Basically, Astro Airflow is made on Apache Airflow. You know about Apache Airflow. If you don't know, let me tell you. Apache Airflow is an open source project. Okay, Astro Airflow is built on Apache Airflow. So we have used Astro Airflow to make a ETL pipeline. From using that, we extracted data from a GCP bucket. Okay, and then loaded that data into a SQL server. Okay, that is your PostgreSQL. Okay, in generally industry level we don't use MySQL, we generally use PostgreSQL. So you will also learn about PostgreSQL, how to make ETL pipelines. I have told everything. Okay, so we have done ETL pipelines also in one of our project. Then what is this Redis? Maybe most of you will be hearing this name for the first time. So basically it is a feature store. Okay, suppose you have done your data processing. Okay, you have done your data processing. Now you want to, after data processing you will get some output. Okay, you will get some suppose training data. Okay, you want to store that training data somewhere, but you don't want to store it in a file form. Okay, you want to store it in a server. So Redis is a feature store server. So you can store your all the features there, and at the time of model training, you can extract those features from there. So it is a feature store. You have other feature store also like Feast. Okay, but Redis is the most common one, and it is also available online. Okay, so in one of our project, we have done feature store using Redis, and you have done after data processing, you have stored your features. After, during model training, you have extracted your feature from Redis. Okay, so you will know each and everything about feature store in that project. Okay, after that, we have DVC. We have used DVC for two purposes. First of all, its main purpose, the full form of DVC is data version control. Okay, so we have used it for data versioning. Okay, we have used it for data versioning. It is the main purpose of DVC, right? But we have used for one more thing. We have used it for making training pipeline also. Okay, and it is a more advanced training pipeline. Okay, so we have used DVC for two purposes, and I think in different projects, right? So you will get to know how to do data versioning using DVC, how to make training pipeline also using DVC in different projects. Okay, so you will know too much about DVC. Okay, okay. Then we have our next library, that is LEP detect. Now, what is this LEP detect? Okay, now this LEP detect, Prometheus, Grafana, we have done in the same project. Okay, what LEP detect help us do? It basically detects data drift. Okay, what is meant by data drift? Suppose there is a change in your training data. Okay, you have trained the model on a specific data, but when you are getting new data from the user, that is quite different from your training data. So that is known as data drift. So this LEP detect help us detect that data drift. Okay, and what is this Prometheus and Grafana? Basically, these are used for your ML monitoring. What? ML monitoring. Okay, so for ML monitoring we will be using Prometheus and Grafana, right? Basically Prometheus is used to capture metrics or make your own custom metrics, and Grafana is used to make beautiful dashboards based on those metrics that were collected by Prometheus. Okay, so these two both work hand in hand. Okay, Prometheus is nothing without Grafana, and Grafana is nothing without Prometheus, like that only. Okay, so they have a very strong bond between each other. Okay, right? So in many of the MLOps project, okay, you will be using Flask for making your user app, right? But in one of the project, we have used Fast API to create an API. Instead of a web app, we were creating API there. Okay, and we also tested that API using our Postman. Basically, there are two ways to test your API. You can either use your inbuilt Swagger UI, or you can just install a third-party app, that is your Postman, to test your API. And Postman is a more reliable method because it helps you store your API calls and all. Okay, so we have discussed about that in one of our project, right? Okay, so we have also used other things also like GitHub for our data versioning, sorry, code versioning and all, right? So GitHub is a very common thing everyone uses, right? So I didn't mention it here, right? So these were all the tools that were basically the MVPs of our course. Okay, and if I talk about the projects in the course, okay, although you have seen the syllabus, but let me tell you about the my favorite. Okay, so it is hybrid anime recommender system. I'm an anime fan. Okay, so I have made a one project anime recommender system, and I think it's one of my favorite. And another one is where I have used VM instance and I have configured that VM instance thoroughly. Okay, and I think it is the last project only. Okay, we have also made project for colorectal cancer prediction, weather, Australia weather, rain prediction. Okay, but my favorite is still anime recommender system. Okay, and it's, I will say, difficulty wise hard. Okay, concept wise hard. Technologies are not that much hard. Concept wise, that is hard. But the last project, okay, your last project, that is your smart manufacturing efficiency prediction, it is hard technology wise. Okay, so these two projects will be very fun to work. Okay, one is your hybrid anime recommender system, one is your smart manufacturing efficiency prediction. Okay, so I will say these are my best two projects that I have made. Okay, so that was all for the introduction of the course. I hope you will enjoy this course and happy learning to all of you. Okay, thank you.